Hey guys, so we're starting a new section today. I think this can be kind of fun. We're just following a pattern. So as long as you use these rules properly, this should be an easy day for us. Okay, so first and foremost, I want to point out that all of the formulas are right here on your paper. You do not have to memorize them, but as you use them, you'll start to memorize them anyway. Okay, so first we have the product rule. Basically, what that is, the product rule, is if we have a product, in those parentheses we have a product of two values, we can add those two values together as separate logs, and it means the same thing. And something we sometimes forget is that an equal sign goes both ways. So if we want to expand, we can move to the right, but if we have something expanded and we want to condense it, we can move to the left. All right. Quotient rule, we have division, which is why we have quotient. That's just subtraction. So those two rules, we know that multiplication and addition go together, and we know that division and subtraction go together because we talked about those with our exponents. So it's really not that different than those exponent rules we learned a couple months ago. All right, our power rule is a little strange. What happens is if we have an exponent, that exponent jumps out to the front. So basically this exponent just moves forward. Okay, and then the change of base formula, we'll go over this in just a sec, but basically what we can do is we can change our base to base 10 because our calculator is in base 10, not in any other base. So if we have something, for example, we have log base 3 of 7 over here, we can change both of our bases to 7 and then do log base 10 of 7, log base 10 of 3, doing the division of these two values, and we can find that. But we'll get to that in just a second. We're really going to focus on these three today. We'll kind of touch on the other. These are just some general properties. You've seen those before. We're going to jump straight into some examples today. Okay, so I have log base 4 of 10x. Something I want you to keep in mind is that the base really doesn't matter. It doesn't influence how we go about doing these problems. The rules stay the same. So if we have 10 times x, and it asks us to expand, we want to expand all the way, no matter what. What we're going to do is we're going to change this to be an addition problem. So I'm going to have, I have two values, 10 and x. So this is going to become log base 4 of 10 plus log base 4 of x. The base doesn't change. The only thing that's happening is I'm basically taking these two things and splitting them apart. But the log stays. All right, we're going to say 2 for practice. ln of 19 divided by x. So if I have division in a log, remember ln is a log, just a natural log. Then it's subtraction. So what this ends up being, my base doesn't change, so I keep the ln of my numerator minus ln of my denominator. Easy as that. We're done. All right. Number 5 is that power rule that I was talking about. So if I have log base 5 of 7 to the 4th, this exponent right here is going to move out to the front. So this becomes 4 log base 5 of 7, and that exponent goes away because it moved out to the front. Okay, so I want you to pause here and do 2, 4, and 6 on your own. I'm going to keep moving because time is different on this side of the camera. So remember, multiplication, we have addition. Our ln stays the same. So I'm going to change colors just for dramatic effect. So I have ln of 7 plus ln of 5. For 4, I have log of x divided by 2. Division means we're doing subtraction. So I have log of x minus log of 2. You don't have to put those parentheses, but sometimes they can be helpful. For ln of x to the third, this exponent is going to move out to the front. So this becomes 3 ln of x. And I always like to put my ln and log in cursive. That way I don't get, sometimes the L can look like a 1. So that's why I do that. Okay, I have got 3 more challenging problems here where we do multiple steps in one problem. So let's just kind of note what we've got going on here. We've got an exponent, we've got a square root, we've got some multiplication in here. This is x squared times that. What I'm going to do is I'm going to rewrite this as log base b of x squared times, we can rewrite this as y to the 1/2 if you think back to last chapter. Okay, it looks maybe less scary now. Let's go ahead and split that. So I have multiplication. Let's undo that multiplication by making it log base b of x squared plus log base b of y to the 1/2. All right, looking at just this side, you'll see that I have that exponent there. Easy, just moves to the front. So I have 2 log base b of x right there. Looking at this other one, again, I just have an exponent. It's going to move to the front. And that's it. We're done. We just have to do multiple steps. Break it down just as we know it. This next one here should be a little bit easier. I would pause, maybe do the next 2 on your own. Otherwise, I'm going to keep going. So I have ln of the square root of x. I'm going to rewrite that as ln of x to the 1/2. That 1/2 is just going to move out to the front. 1/2 ln of x. All right, finally, our last example. Got log base 6 of x to the third over 36 to the y. All right, don't like the division. Let's get rid of that right away. So I have log base 6 of x to the third minus log base 6 of 36y. Let's just focus on the first part here. I can clean that up real nice. Just move the 3 out to the front. Okay, and now let's look at, I'm just going to rewrite this as because of subtraction here. So I don't mess it up, I'm going to go ahead and put parentheses because we're going to do some stuff. I meant to write in blue, it's fine. All right, just rewriting this, just brought it down. I have multiplication here. If I were to ignore that subtraction sign there, this is just going to be log base 6 of, my goodness, of 36 plus log base 6 of y. Oh my gosh. Okay, so there, we're done. We've expanded it all the way. It's broken down. You can distribute that negative through, but it's really not necessary. We've expanded, and so we're done. All right, let's do some problems going the other way.